Hello everyone, my name is K. Rani. My roll number is 22955805 I am studying at Institute of Aeronautical Engineering. Today I am going to give a presentation on classification of materials based on energy band. So my topic contains our energy band theory, and in it what is valence band, what is conduction band, and what is forbidden band. Classification of materials based on energy band. So uh, what are the classifications of materials based on energy band? That is conductors, semiconductors, insulators, and conclusion. So let's see energy band. According to Bohr's theory, every shell of an atom contains a discrete amount of energy at different levels. So energy band theory explains the interaction of electrons between the outermost shell and the innermost shell. Based on energy band theory, there are three different energy bands. So energy band theory just gives the how much of energy that atom is having. So energy band theory explains interaction of electrons between the outermost shell and the innermost shell. Based on energy band theory, there are three different. So interaction between the outermost shell and innermost shell. Based on the energy band theory, there are three different energy bands. So the first one is valence band. The electrons in the outermost shell are known as valence electrons. These valence electrons contains a series of energy levels and form an energy band known as valence band. The valence band has the highest occupied energy. So the electrons in the outermost shell are called valence electrons. These contains a series of energy levels and form an energy band known as valence band. The valence band has the highest occupied energy. So this is the highest occupied energy in most of in a conduction band and in forbidden gap also. Okay, coming to the conduction band. The valence electrons are not tightly held to the nucleus, due to which a few of these valence electrons leave the outermost orbit even at room temperature and becomes free electrons. So which are valence electrons? They will be at valence band. If So these are not tightly held to the nucleus, due to which a few of these few of valence electrons only, leave the outermost orbit, even at room temperature, and become free electrons. The free electrons conduct current in conductors and therefore known as conduction electrons. So these which leaves the outermost shell and comes out of it are called free electrons and conduct current in conductors and are therefore known as conduction electrons. The conduction band is one that contains conduction electrons and has the lowest occupied energy levels. So comparing with the valence electrons, so these are the lowest occupied energy levels, and valence are highest energy levels, highest occupied energy levels. So let's say forbidden energy gap. The gap between the valence band and the conduction band is referred to as a forbidden gap. The name suggests the forbidden gap doesn't have any energy and no electrons stay in this band. So first there will be like valence electrons, and there will be a gap between the forbidden between the valence levels and conduction levels, and then after the conduction level. If the forbidden energy gap is greater, the then valence band electrons are tightly bound or firmly attached to the nucleus. We require some amount of external energy that is equal to the forbidden gap energy gap. So, if the forbidden energy gap is greater, then the valence band electrons tightly coupled or firmly attached to the nucleus. So, valence electrons are tightly coupled, tightly bound or firmly attached to the nucleus. We require some more energy. So, some more energy is equal to the forbidden energy gap to become the conduction electrons. So, classification of materials based on energy bands. On the basis of energy bands, materials there are classified as insulators, conductors, and semiconductors. Here, conductors. So, as we know generally, conductors are like conducts the electricity. Conductors are materials that allow current to flow easily. When conductors are semiconductors are compared. When conductors and semiconductors are compared, conductors enable better current flow, and are said to be good electrical conductors. So conductors always conducts electricity, but semiconductor sometimes conducts and sometimes may not be. So conductors enables better current flow and are said to be good electrical conductors. Categories of conductors. Metals. So there are three types of categories of conductors. They are metals, non-metals, and ionic conductors. Let's see metals. Most conductor materials are used in practical applications of metals. For example, the wiring used in a house probably employs copper wire or its alloy as a conductive material. So uh, we can see in a house that there will be wire, okay, which is copper wire, or its alloy as a conductive material. So these are like conductive material. This is because metals have many free electrons and promote mobility. So they have more free electrons, they can be moved. A few of the best metal conductors are silver, copper, and gold. So coming to non-metals. Some non-metals are very good conductors of electrical energy. For example, carbon in the form of graphite is very good conductor. Looking at the structure of graphite, only 3 of 4 carbon atoms are used for bonding. This releases the electrons and binds them together. Most nonmetals are poor conductors of electricity. So most of the nonmetals are poor conductors of electricity. Some of them are good conductors of electrical energy, but most of them are poor conductors of electricity. Ionic conductors. Conductors in a solution form are known as ionic conductors. So these are the solution forms. For example, salt water, ionic solution, and is an excellent electrical conductor. So as we see categories of conductors, there is metals, non-metals, and ionic conductors. Metals are good conductors of electricity. Non-metals are somewhat non-metals. Some of them are very good conductors of electricity, and ionic conductors are in the sense solution in the form of liquid. They are they are known as ionic conductors. So examples of metals are silver, copper, gold, and coming to the non-metals, there will be like graphite, which is a very good conductors of electricity. Carbon in the form of graphite is very good conductor of electricity. An ionic conductor example is salt water. Semiconductors. Semiconductors are materials that exhibit conductivity between conductors or metals and non-conductors are insulators. Semiconductors are mixtures such as gallium arsenide or pure components such as germanium and silicon. So these are the materials which can conduct electricity and may not conduct electricity. So the semiconductors are mixtures such as gallium arsenide or pure components such as germanium and silicon. So coming to the categories of semiconductors, there is intrinsic semiconductor, extrinsic semiconductors, and insulators. So intrinsic semiconductor materials are chemically very purely made. They consist of only one element type, so these are mostly pure, and they are not mixture of one of two alloys or materials. When the temperature rise due to collision, some electrons move freely in the lattice without being bound and do not exist in their original positions holes. So when they collect, when the temperature rises, they move from their original positions. These free electrons and holes contribute to the conduction of electricity in the semiconductor. So these the free electrons are the capable are the reason behind conducting the electricity in semiconductors. The number of negative and positive charge carriers is the same. So the number of in any of the circuit, the number of positive and negative charge carriers are the same. Extrinsic semiconductors. Semiconductors, the conductivity of semiconductors can be significantly improved by introducing a small number of suitable surrogate atoms called impurities. So, as I said before, intrinsic semiconductors are pure. They cannot be, and they are pure. They doesn't contain any other type of element. But coming to extrinsic semiconductors, they are mixed. They can be mixed with impurities. The process of adding foreign atoms to a pure semiconductor is called doping. So in the extrinsic semiconductor, doping is happening. And the insulators. So the category is insulator which doesn't conduct the electricity. So third one is insulator. Electrical insulators are different from conductors. They are totally opposite to the conductors. Conductors are materials that propagate the ease of current flowing through them. They allow charge to flow easily. Insulators, on the other hand, are materials that do not allow electric charges to flow freely. So that they doesn't allow the current to pass through them. So some of the applications of insulators are primarily used when it is necessary to prevent the flow of charge. So when to reduce the charge or when to the stop. If there is more current flowing with the wire, we should stop. So they can be used by insulator. These materials act as effective insulators because they do not have the moving charge required to propagate the current. So they doesn't have any moving charge required to propagate the current. Electrical insulators are mainly used as parts of electrical equipment. So they are a good part of electrical equipment. So when conductors are going to conduct the electricity, semiconductors are going to conduct the electricity. Some of them may act as insulators also, but coming to the insulators, they all doesn't conduct the electricity. So we have discussed three types of materials based on the energy bands. So let's see how, by seeing this, how they how they are how the energy how the element energy is going to be decided. Let's see. First, to see conductors. They have free electrons, so they are easy to conduct. Means they are easy to conduct the electricity. From the valence band, they are easily going to conduct the electricity, and they will be moved to the conduction band. And semiconductors, there is a band gap between them, between valence band and conduction band. To conduct the electricity, they have the they have the gap between valence band and conduction band, right? Some of them only move to the conduction band if the temperature is raises. If the free electrons are there, then only the electrons move to the conduction band, and the energy is flowing upwards. Insulators, they doesn't conduct the electricity, right? So even though they have elements in the valence, in the outermost shell, they are not going to connect the electricity. So they have a big gap of band gap, which is we also call, which is forbidden gap. So as we observed here, in conductors there is no forbidden gap, so they can conduct the electrons easily. They can they can conduct the electricity easily. And coming to the semiconductors, if there is a rise in temperature, if there are free electrons in the element, then they can pass the band gap and conduct the electricity. Some of them conduct the electricity by going to the conduction band. And insulators, there is a big gap of band gap, which is forbidden gap, so they cannot going to conduct the electricity. So conclusion, while the classifications of solids is done based on band energy into conductors, semiconductors and insulators, they all have their respective applications in different fields. Examples of conductors are gold, silver, aluminum, and copper. Semiconductors are gallium, arsenide, germanium, and silicon. And insulators include rubber, plastic, wax, wood. So these are the insulators. So let's revise. So we have seen a band theory. So it is used to give the relation between outermost and innermost shell. So it contains three parts. They are valence band, conduction band, and forbidden band. So valence band means free electrons. So conduction band, which conducts the electricity by going to them. And forbidden gap, the gap between the valence band and conduction band. And we have also seen the classifications of materials um, based on the energy bands. And there are three types. There are conductors, semiconductors, and insulators. So conductors are easy to conduct the electricity because they have valence electrons, and they have free electrons, so easy to conduct the electricity. So there is no gap between valence band and conduction band. And coming to the semiconductors, if there is a rise in temperature, if the electrons are free, then only they can pass the forbidden gap, which is small, and they can conduct the electricity by going to the conduction band. And coming to the insulators, so insulators do not conduct electricity, which means that the electrons in the valence electrons don't have that much of energy to pass the forbidden gap and conduct the electricity in the connection band, right? So they'll be staying at the valence band only. So we have done classifications of solids based on the band energy, and examples of conductors are gold, silver, aluminum and copper, and semiconductors are gallium arsenide, germanium and silicon, and insulators include rubber, plastic bags and wood. Thank you.